Hello everyone, today I want to show you how we can solve this second order differential equation. So this may look difficult at first, but there will be 2 points in this video where you're going to notice that this is much easier than it looks like. And the first point is, you can make a substitution to turn this into a first order differential equation. Let me show you this. You could just say that let the letter r, let's use that, let r be equal to y prime, okay? Because if you do that, you're gonna be able to rewrite the differential equation like this. You're gonna have x times y double prime. Well, y double prime is gonna be r prime. So r prime plus y prime, that is r, is equal to 12, okay? So I hope that you can notice that this is a first order differential equation, okay? Now, most people, what they would do is they would do this. They would, okay, divide both sides of the equation by x, and then that's gonna give them r prime plus r over x is equal to 12 over x, okay? But there's something much smarter that you can do. If you take a really hard look at this equation, well, you're gonna notice something. This is the same as if you just had the following derivative. ddx of r times x, okay? Notice that if you differentiate this with the product rule, you're gonna get dr dx times x plus r times the derivative of x with respect to x, that means r, okay? So you get dr dx times x plus r. That's exactly what we have here, okay? So then you can rewrite this differential equation as the derivative of r times x is equal to 12, okay? And now, if you want to solve for r, which is our goal with this differential equation, well, you can just integrate both sides of the equation with respect to x. Okay, so that's gonna look like this. I'm gonna continue down here. We're gonna be doing ddx of r times x dx is equal to the derivative of 12 dx. Okay. And now notice over here, we're just gonna get the integral of the differential of the quantity r times x, and this is gonna be equal to 12x plus a constant of integration c, okay? Now, if you integrate the differential of a quantity, you're gonna get the quantity, meaning you're gonna get r times x. So we have r times x is equal to 12x plus c. And to find r, well, the only thing we have to do is just divide by x on both sides of the equation, which is going to give us 12 plus c over x, okay? And this is our result for r. Now, we're not done yet. We have found r, but we want to find y, okay? But we know that r is equal to y prime, so we can say the following. We can say dy dx is equal to 12 plus c divided by x, okay, meaning r, okay, because this is the original substitution we did, so now I'm undoing it. And now this is a separable differential equation, and I'm pretty sure you know what to do from here. You would just, integrate both sides of the equation with respect to the corresponding variables, and we're gonna get that y is equal to 12x plus, this is going to be ln of x, remember, and the absolute value of x, because we don't really know the domain of our function, it could be negative, so we're going to keep the absolute value plus a constant c, okay? And well, I missed the, so my apologies, I should have written this constant c, let's call that c1, okay? So I'm going to call this c1, I'm going to begin calling it c1 there, because here we're going to get a second constant of integration. So we're going to have c1 times ln of x, this is an n, times ln of x plus c2, okay? And this is our result, this is our answer for that equation up there. And I think we should check if this is true. So let's find the derivatives. First we're going to do y prime. We know y prime is going to be the derivative of this, that is 12 plus c1 over x, and then the derivative of c2, that's just 0. And now let's differentiate that again to get y double prime, and the derivative of this, that is x to a -1, so we move a negative in front, and we have -2, so we get minus this quantity, okay? And now let's see what we get. So that differential equation says that if we multiply y double prime by x and we add y prime, we should get 12. Let's see what we get. So x times y double prime, that's going to be times c divided by x squared plus y prime, and that's going to be 12 plus c1 over x, okay? And this was c1, my apologies. I'm not really good at keeping track of subscripts. I should, when I'm doing physics, I can do that pretty well, but when I'm doing math, sometimes I don't know why I leave them behind, so keep an eye out if I do that. And now I think it's obvious, right, what we're gonna get. We're gonna get that x, y double prime plus a plus y prime is gonna be, this quantity becomes minus c1 over x plus 12 plus c1 over x, and this is indeed equal to 12, okay? Which is what we presumed this expression should be equal to. So that means that this solution is correct, okay? So I hope you enjoyed this video, I hope you learned something, and I hope to see you in the following one. Bye.